Hey there, seniors. What a week it's been. I'll tell you what, rain, rain, rain. So, the great thing about rain, when you're talking about fluvial geomorphology, is you can really start to think about your situation in the context of the water cycle and in the context of the shape of the land. It is a wonderful thing to be able to contemplate runoff and infiltration in such meaningful ways. So, hey, as we get into Thursday, you guys just spent a class period muddling through how to classify streams. Well, not only by stream order, but by reach type. So, kind of cool what you were doing. So, if we're on Thursday, of course, we're going to look at Holman's Creek entirely. So, Holman's Creek, of course, enters the North Fork over here. And if we zoom in a little further, we can follow it along here. And note that Holman's Creek keeps on going. Now, these little blue lines are kind of hard to follow after a while. So you can, of course, add a few more layers. What I'm going to do is go to my layer list up here in the national map. And this is really a great thing to use here. I'm going to go ahead and click on the National Hydrography data set, which will accentuate Holman's Creek for me and allow me to follow it perhaps a little more easily. It gives me a little bit different colored blue, at least. Also shows me the flow directions. And the magnitudes of flows. So these are intermittent streams where you see the dash, dot, 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 dash, dot, 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 and so forth. Holman's Creek, of course, all the way back to its source, or way back here anyway, is still, of course, a flowing stream. Of course, Holman's Creek, you ask yourself, well, why is it flowing so much? Because it's being fed not only by overland flow from rain events like we've been having for pretty much the last, who knows how long. Not even sure what the sun looks like anymore. But because it gets fed by springs. And so here's by the way, one farmer who years ago built a dam right here. And these drawing tools, look at that. I can draw. That's awesome. Okay. Anyway, moving on. I'm going to go ahead and actually erase that because it's going to apparently follow me everywhere I go. If I keep on following Holman's Creek, it, of course, it's another little dammed area. I could come up with a damn joke, but that's wouldn't be too funny, I'm sure. So if we keep on following Holman's Creek, of course, these other streams feed into the little lake there, little pond. But Holman's Creek keeps on going, just keeps on going. Now this time, of course, we're running now parallel to the valley and ridge. And eventually, we are going to hit the beginning of Holman's. Look at this. Now, Holman's then turns into an intermittent stream where it becomes a first-order stream at this point. So here it is, a first-order stream. And then, of course, it's essentially a second-order stream and so forth. So, but anyway, if I wanted to look at, of course, what Holman's looks like across this reach of it, I'm running through a valley here. There's not a whole lot of gradient change. So if I'm interested in, classifying it as by type, I'm going to go ahead and look at the profile here. If I pull that up, the elevation profile, and go ahead and click measure under the measure tab here, and I want to go from, say I want to go from this point where Holman's essentially becomes a full stream at all night and day, to this where it meets up with this next little stream. And I double click there. It's going to calculate my profile. And you can see here the distance in miles is, we got 0.8 miles, which if I calculate that distance, I'm trying to get my other, excuse me. Wow, nothing's working. This is great. My computer's frozen. So there we go. Now it's unfreezing. Of course, if I make a quick calculation, 5,280 times 0.8, which comes out to 280 times 0.8, that comes out to 4,224. Of course, that should be approximately what let's give me 2 miles. If I put it in feet here, it should give me the result I'm looking for here. So yeah, 4,295.5 feet. Now my elevation change from point A, which is, you can see where the X is following over here, That's where I have, and as I move along this profile, it shows you where you are. So I'm starting out at 1360, roughly, maybe 1362, and going all the way down to 1313. So 1362 minus 1313 is going to give me 1362 minus 1313, 49 feet. So I have 49 feet in elevation change divided by 49 divided by 4,295. We'll just say 4,295 feet. Gives me an answer of 0.011. And if I then multiply that by 100, it gives me a gradient of 1.14. Now, if I look at my Rosgen level 1 diagram here, once it lists 1.1% is, of course, less than 2%. It's also less than 2%. So it could really fall in any one of these categories here, C through F. The trouble is I have to actually decide which is in plan view. And that's a little bit more challenging. So if I look at it in cross-section, which I have to go down to the stream to look at it, and we'll do that. We'll create a cross-section where it'll help us narrow that down. And that's one of the first things we're going to do on Tuesday next week. But if I'm just going with it now, it could be a C-type stream, or it could be an F-type stream. It's definitely not meandering this much, and it's definitely not anastomosing or braided. So, but if I go back to look at it, here, it's really a pretty straight stream. So if I'm going to hazard a guess, I'm going to call this an F-type stream along this reach of Holman's Creek. So all I would do is simply write in here this as an F, and I would go ahead and mark this over here, and that's an F-type stream in there. Okay. So I'm going to go ahead and erase that, because we're going to go ahead and look at another reach of the stream and see what we can do there. All right. So let's zoom out a bit. Follow Holman's Creek back down to where it becomes a little more interesting, perhaps. All right. So good old Holman's Creek. We're following along. You can see Holman's Creek's behavior is, one could ask yourself, is it dictated by the landscape, or is the landscape dictated by Holman's Creek? This is a very interesting question. So anyway, we're going to go and look at the stretch that we're going to be most interested in is actually going to be this stretch, this reach from here to here roughly, and then again from here to here. And this is going to be our reference reach over here, and this is going to be our study reach, actually somewhere in this vicinity. All right, but let's say I wanted to actually go and measure what the gradient situation is from, say, where this confluence is to where it hits the North Fork, or actually, because it's really, we're down into the entering the valley here, and our gradient's not going to be that much different. I can tell you right now, our gradient's going to be less than 2% again. So then we have to ask ourselves, of course, it's meandering a lot more than it was. And so can I make an argument now, if the gradient's still less than 2%, that the stream is more like this? Well, maybe. Or maybe it's more like a C-type stream along that reach. So that's kind of what we're looking at here. You would, again, make a demarcation line there and make one here, and then decide, okay, I think this is more like a C-type stream along here. So then I would simply go and put a C there. And that's how that works, okay? Then we would go out into the field and we would validate that. Okay, so let's talk about sinuosity. Sinuosity is calculated as the channel length divided by the length from point A to point B, essentially. So in order to figure that out, obviously, I don't need an elevation profile anymore. So I really just need a distance measurement. So that's all I'm going to choose here. I'm going to go. There's several options here. You can choose location, distance, or area. I'm interested in distance, and I don't want miles. I want it. I want it to be dimensionless again. So I want to, I could use miles actually, but I'm going to go with feet over feet. Okay. So the first thing I'm going to do is I'm going to go ahead and say I want to know the sinuosity of Holman's from here, this point, over to where it enters the North Fork. Okay, so my distance overall is 6,683.4 feet. I'm going to write that down. Okay, now the next harder one is actually, I'm going to zoom in a little bit here. Now I'm going to go ahead and mark, I'm going to remeasure this, and I'm going to do my best to follow the course of the stream, but I'm not going to double click until I'm down at the end, because that's essentially where I'm going to be ending it. So this takes a little bit of time. You have to be a little patient with yourself, and it's a good form of meditation. If you're a really stressed person, this could go either one of two ways. It could either actually increase your stress or significantly decrease it if you use it as a form of meditation. I would recommend taking deep cleansing breaths before and after you begin this process, because as you can see, it is a bit tedious. But for some people, tedious activities can be very fulfilling. So as I do this here, I'm only feeling a slight amount of stress. So for me, I'm an innovator, right? So this kind of detail work is necessary, but it's one of those things I have to use coping strategies to manage. Now, for some of you folks who are more adaptive, you're going to really love this activity, because you're going to find it to be so precise that it's going to be very exciting to you. So anyway, I'm almost done here. So I will continue until I hit the North Fork, and then I'm going to double click. And there we go, 9,914.4 feet. So now I need to make a simple calculation. So I'm going to take and write in 9,914 divided by, I'm just going to round my other number up to 6,683. All right. Actually, I've got this backwards. I want to take this, put that as my denominator. All right. And this is going to annoy some of you, but I'm just going to leave that like that. That's right. So it's actually 6. Now I've got that backwards. I was right the first time. I have to remind myself. Okay. 9,914 divided by 6,683 equals sinuosity. Okay, so if I do that, you can calculate along with me. Say it aloud. It's a whole lot more fun. 9,914 divided by 6,683 gives me a sinuosity of 1.483. Now, the other day when we looked at this, that was right about the definition of a meandering stream. So no, we have a meandering stream here. Anyway, that's how we calculate sinuosity. We take the channel length divided by the map length, map distance. And so your bigger number should always be on top. Obviously, if these numbers are equal, if the top is 6,683 and the bottom is 6,683, your sinuosity equals 1. And what does that mean? Well, it means that you have a straight channel. I could have calculated this with the first piece of Holman's Creek we looked at, and that would have very nearly been a straight channel, no sinuosity. This calculation will become very useful later on in our characterization of the stream. Sorry about the little math error there, but it is what it is. So I'm not going to remake this video so I can eliminate the error. So you just have to deal with it. All right. Hey, now that this is over, if you really feel that you need to take some more stress out, go and measure some sinuosity in some other streams. It really does make a difference. Until Thursday, I will, hope you have a good couple of days. Thanks.